Hi, everyone. Welcome to our session today. My name is Moria, and I'm from the Reactor team, the Reactor in Tel Aviv. For those of you who don't know the Reactor is a technical hub for developers and startups. We are based in 12 locations globally, but we also have, of course, online event we offer from anywhere in the world. So today's session is going to be on GoL clinics for data, exploring the fundamentals of real-time analytics. I'm gonna do a quick introduction of Paul DiCarlo and Ismail Mejia, our speaker, and for today. So Paul, I'm gonna hand it over to you to start the session. But just before that, I wanted to tell all of everyone that's here, the session is recorded. If you want to ask any questions, you can just put your questions in the Q&A or chat box, what you see on the screen. Please feel free to post your questions there, and we will take the time to answer. Anything else, please free to put it in the chat, and I will be here through the session and help with the moderation. So, Paul, over to you.
Yeah, thanks for introducing us, Mariah. So happy to introduce folks to our third session here for the GoL Clinics for Data. This one's going to be presented actually by Ismail. He's going to be leading off everything here. I'm just going to be in the background moderating and answering your questions. So for folks who do have things to say, I'll be here, providing links to documentation, anything like that. And without further ado, we'll pass it over to Ismail, who's going to be delivering the majority of the presentation today.
Okay, thank you, Paul. Thanks everyone for joining us today. We're going to talk today about real-time analytics on Azure. So this you will meet this link that you can follow just to see the training module that we are going to present today. I work at Microsoft as a cloud advocate, and well, let's learn a little bit about all the systems. But first, let's remember that we are running this program that is the Game of Learners Data Clinic. This is a 5-week program that we have been following. In case you missed the previous sessions, you can find them online in the YouTube Reactor channel. And this week, we're going to talk mostly about real-time analytics and streaming. So today, we're going to talk about the fundamentals. But you also can join the following weeks for other services like Cosmos DB and more about Synapse. Also, let's not forget that all of these sessions are in part to prepare everyone to present the DP900 certification. This is the Azure Data Fundamental certification. And if you follow all of these modules, as you follow all of them online, not the videos, not the actual talks, but the training modules on the Learn page, you get the possibility to have a pass to present the exam. So you have a voucher, and this is for the 200 first people who finish all the modules that we are presenting in this Game of Learners path. Of course, if you want to, you have more questions, you can put them in the link below in this Data Clinics forum for more technical details. But for today's subjects, you can ask in the chat, and well, we will answer them. So obviously, this is learning is an interactive experience, and well, we all want to share what we know or what we don't. So don't hesitate also to introduce yourself in the chat and where do you come from, and well, ask questions and share what you understand or you don't, and let's make this more live. Okay, so let's talk about the fundamentals of real-time analytics. And well, before that, there is one last thing. I just want to remember that all of you that there is this link, aka the .ms Azure Explore Real-Time Analytics, which will redirect you to the module we are going to present today. This is a long module that is going to take like 1.5 hours. We are going to try to make it a little bit faster, let's hope, so we can cover everything. So if you can follow on your own, I will present some of the slides are exactly the same text that you will find in the web page. So okay, so what are your objectives today? We're going to talk about the difference between batch and stream processing, and well, for some of you who are familiar with this could be clear. For others, well, we will see what is the difference. Batch is basically what we do with traditional databases and with batch jobs. We are going to describe the particular elements of a streaming data solution. And with that, we are going to see 3 different ways how you can do it in Azure. One is with Azure Stream Analytics, another one is with Spark running on top of Synapse, and the last one is with Synapse, the Data Explorer. All of these three modules, we're going to describe how they work, but we're going to focus also mostly in the exercise part. We're going to see how they work in real life. So let's first do a tiny introduction. All of this need for analytics and data processing in a massive scale, it's triggered because of many things. Now we have the growth of smart devices with internet access, and this is these IoT things, but also telephones, just people doing activities with their phones, playing video games, or just interacting in social media. All of this has created a massive volume of data that can be generated that we can, from the point of view of the providers, capture and analyze to improve the products and the experience of the users. So with this massive need for data, we get into a massive need, into a real need for to answer queries and have information about this data in a faster way than with traditional databases. This is the key interest of having stream systems. And what is the difference between batch processing and stream processing? And well, before that, what we talk about when we talk about data processing. So data processing is taking the raw data that we capture from these devices, and we process this data, we transform it, we aggregate it into something that gave us meaningful information. So we can do this with existing data. This is what we call batch data. We have already collected all the information, maybe in a table of a database, and then we run a query on those data. This is the traditional batch processing scenario, but we also have the stream processing scenario, and this happens when we have data that is constantly arriving. So what we mean with constantly, we mean that it's continuous. All the times is still arriving. If you think about, for example, Twitter interactions at this moment, everybody's writing new tweets and they are continuously arriving. If we want to count how many tweets we have processed, well, it's not as simple as because, well, it's already there now. As an example, we can imagine, for example, this scenario where we want to count how many cars are passing now through a road. And well, in batch processing, what we will have is to collect all the cars and count them when they are together. But well, in real life, this is convenient because, well, we can do it, for example, and this has been the tradition in the industry to run this in the late night jobs when we aggregate all this data and put the data into a new database or data warehouse. But with the increased need of quick response and short latency, well, we have to do this in real time. And this is what happens in stream processing. If we are counting the cars here, what is happening? As you can see here, we are counting the cars. There are 3 cars in one second, let's say, or 1 minute. Let's assume that this is 1 minute. And as you can notice, there is one first element that appears here in stream processing is the dimension of the time. So time matters for all this analytics because we cannot have aggregate all the time in the world for the data because, well, we don't have that much space. So usually we have short retention times and we aggregate this data. And what kind of systems do require this? Of course, if you think financial systems are the key example because they want to react as fast as possible to the variation in prices in the different stocks in the market. But it also happens a lot in online gaming. For example, if you join one game and we have to pair you with your rivals for the game or your team, well, we have to estimate quickly, okay, you are part of you have these skills, you have this experience, now I put you into this. And then after you play, we refill this loop. So all these systems are useful for that. So what are the differences, no? One thing, the first thing we can talk about here is the data scope, no? And as I said, well, we have data that is more recent, more fresh in streaming than in batch. The other thing is, well, stream processing is usually you have data sets that are smaller in the sense that, well, you are grouping what is going on, which is probably way less than what you have historically, in the system. If you have been running the system for 20 years, well, so obviously what is happening now is smaller than in the past. Of course, well, as you see, well, latency is key and is tolerated in batch systems. In a streaming system, is more critical. So as fast as we can produce the results, the best now. And finally, both of those systems are used to produce analysis and aggregate data and produce, for example, the one key difference is that with batch systems, we produce reports, let's say, that are more static. With the streaming system, we produce dashboards. And that's why some of these streaming systems are used into monitoring systems, like Azure Monitor, for example. We'll talk a little bit about that just later. But in real life, what happens is that we cannot have one or the other. We end up having a mix of both type of systems. Why? Well, because we have legacy systems who already are batch-oriented, but we also want to have more reactivity with this upcoming data. So what happens commonly is something like what we illustrate in this image. We have events or data that arrives into the streaming system and are captured in real time, for example, or the actions you did in the game, for example. But we also have historical data that we have in our systems, like previous processes that we have run. And usually those are stored in what we call a data lake. So usually it's a different, can be a database also, but well, yeah, it's also common to have it in a data lake. And then, well, of course, if we don't need to process this data immediately, we can store it in this data store. But if we need to process it, we have to run it into a stream processor. And there are multiple technologies for this. We are going to discuss 3 today. And then, well, obviously, with this, we integrate both results, the streaming, the recent results, and the historical results to have a complete view of what is going on. We do this because we want to have both completeness and fast data. So what are the common elements of a stream processing architecture? So this is also an interesting part. As I mentioned, in this kind of systems, we talk a lot about events, but you can understand event as a row in a table. It's just an aggregation of data, or as a JSON file, for example, a JSON request. And this data is sent into some system who is going to capture them. And this system stores the data. We call this the source of the data, even if the source is the IoT or the telephone producing the data. Well, we call the source of the data stored system. You know? So the data source is something like, for example, well, if you are familiar, maybe there is this thing called Kafka. That is Apache Kafka is a system to store data that is coming into streaming. In Azure, well, we have event hubs, and that is the equivalent of Kafka for Azure. And then we have a query that is running on this data that is arriving, and this query is processing, is taking all this data and transforming it and preparing it so we can use it in different systems downstream. So this is the results are, with these results we can create new files, fill databases, put data inside of database, or work with visual dashboards to report the data. Of course, as I mentioned, and I just want to highlight that there are 3 elements that are key and we shouldn't forget. One is the processor, one is the source of the data, and the other one is the sink of the data, so the destination of the data. In Azure, we have at least 3 technologies that we can use as the stream processor. So it's the tool that we use to do the analytics of the data. This is the tools that we use to transform the data, to aggregate the results. So this is where let's say, if you are familiar with databases and SQL, well, this is when we run the SQL equivalent transformations. So we have first Azure Stream Analytics, and this is a platform as a service solution that we use to ingest data from a streaming source. We apply a query that is running all the time. What is different here from batch systems is that these queries are running all the time. It's perpetually running this query until we stop it. Of course, we can stop it. And it's perpetually writing results into an output. One interesting key thing to remember of Azure Stream Analytics is that the main language of Stream Analytics is SQL, the same SQL that we all know from databases. So that's pretty nice because we can reuse the same knowledge we have into the system. The second system that we can use in Azure is Spark Structured Streaming. And this is a library that integrates with all the big data systems, let's say, like this is kind of Hadoop and of course, Azure Synapse and Azure Databricks also. So, and well, here they mentioned Azure HD Insight is actually the Hadoop distribution that Azure has. So this is a library that is has a different approach. This is more oriented into data frame like programming approach. We will see this in a middle a little bit later. It's a little bit like pandas or this kind of libraries when you do more, you don't do a query, but you do this step-by-step transformations of the data until you get the data in the shape you want. This is how it works. And finally, we have Azure Data Explorer. And this is a mix of a source. So this is a data store when we store the data, and an analytics service. So we can run queries here. This is optimized to really massive amounts of especially time series-like elements. And this we run through a system that we call, it's now integrated with Synapse. It's called Azure Synapse Data Explorer. So one key element to retain here, but we will see this later on, is that this system uses a different query language. It's not SQL. It's a language that you will find there as KQL or Custo, but we'll talk about that later. So that's for the processing systems. No, when we talk about the sources, is where we take the data from, and as you can see, well, we have here Azure Event Hubs. That is the main ingestion service that Azure has. This is basically, you can imagine this as a queue of events. All the data is being stored into an event hub. We have also Azure IoT Hub, that is the equivalent of event hubs, but more optimized for data of IoT devices. We have also Azure Data Lake Store, and you will think, okay, wait, Data Lake, this is like for batch kind of scenarios, but it can be also a source for streaming data. Why? For example, well, because you can be just reading what happens in a directory. Do we have new files? And every time somebody puts a new file in this directory, we read it. And this is somehow equivalent to receiving events, no? And of course, well, we have Apache Kafka. This is an open source data ingestion solution that usually you can install on top of things like Azure HDN site, or even you can run it by yourself into Azure Kubernetes service if you want. But well, in that case, you have to manage the system. If you use Azure Event Hubs, of course, you will have a fully managed system, so it's probably easier. And then those are the systems where we read data from. Now, the system where we write data to are the sync. They're called syncs in the terminology of the streaming systems. And then we have systems like event hubs also. You can read from one queue and put this data into a different queue. Also, you have systems, well, again, you can read the data that is coming in real time and store it into a blob storage or a data lake file system. So you can analyze it afterwards, and you can analyze it even in a more refined format like delta tables that we talk about later also. You can even just record this thing into an Azure SQL database or into a Synapse Analytics also store. And well, finally, you can use Power BI, to generate real-time data visualizations as reports and as dashboards, as I said. So yeah, those are the three elements. And now, well, let's explore the first of these systems. This is called Azure Stream Analytics, and as I mentioned, this system is a little bit the most easy to use because it's just plain SQL, as we probably know if you know SQL. As I said, the input systems of Azure Stream Analytics are IoT hubs or are blob containers or are event hubs. Then we pass through a query, and then we are going to write these results into a destination. And this destination can be any database that we have. We can be even directly into Power BI, but also it can be, well, a data file system. So let's let's run this. Probably is the easiest way to understand is that we run the example. But something that we have to remember is that we have a job that has an input and an output, and that's what we call source and sink, and we are going to be running this query all the time on the data. No? So, of course, well, this is an introduction to all these systems, so we are not going to go really deep into them. We're just going to go into the exercise, and for this, I'm going to run the exercise here. Sorry, I didn't show this webpage that hopefully you are following. It's just what I was showing in the slides. And we are going to jump straight into the exercise. This is the first exercise for Azure Stream Analytics. There are some things that probably are going to take a little bit of time because the time we need to provide the resources. So the first step is just we go into our Azure portal. Let's say I'm going to just refresh this so you see that we are just on the first step. And we are going to open this Cloud Shell symbol. Here is a little bit reduced because my window is small, but you will see. And there you will be with a prompt of a terminal that is connected into all our Azure services. And then you have then you have your system. You can run all of sort of bash commands there. And the first step that we mention here is that we have to clone this project. I'm gonna just I'm just going to remove the previous instance just to show everything. Okay, so here we are. I'm going to clone this. Basically, we are taking this project from GitHub and we are put it in our instance. So let's call this. And step 4 says that we should now enter this command to see the data. So let's go. Oops, sorry. We enter into this directory. It's the directory of the certification about the streaming. Oops, I was already in the directory, sorry. So I'm going to streaming, okay. And then it says, okay, enter this command to run a script that creates the resources that you need for this exercise. So we are going to run this command, but before running this command, let's check it a little bit what is happening in this command. I'm gonna put this a little bit up, sorry. So we are going to first install the extensions for Azure, for the Azure command line to support the streaming, stream analytics, Azure IoT. Then we are going to create a resource group. Here we are creating just an alias for the resource group, and this is a random, as you can see, there is kind of a random number here generated. So we are going to create a resource group with a name. This is a random number. And then we are going to create all of these things. We are going to create our source of data that I mentioned before, the IoT hub. We are going to create our destination of data, our sink, that is the storage file system, let's say. And then we are going to create our streaming analytic jobs. That is where we're going to run. Of course, well, here is a little bit of extra details. So that's all for now. So now let's go out of here. So let's run this. This will take a little bit of time. So checking an instance. You can notice, for example, if you run this on your own at the same time I'm doing it, that you might not see some of these things same equal results because, well, we are creating, for example, I already had these extensions installed. Probably you are going to see the message installed in these extensions. You also will see this. This is the name of the resource group that we created, and this has a random number that identifies this unique instance. And well, just let's remember that resource groups in Azure allow us to aggregate all the services, all the resources that we create. So they are really nice to organize things, and well, to also for these labs are really useful because we can delete everything at the same time and don't pay more. No. So as it says here, while it's creating this, let's review this. Azure, so we first installed the CLI extensions, we created the resource group with all the elements, and we created the 3 elements, just as I show in the file. So this is the same, the same that is explained here. I was showing in the script, in the Bash script. Normally in Azure, you will do these things with templates, with IRM templates, but well, you can also do it like this for the example. Let's wait a little bit until it creates this IoT hub. It's taking some more time than I expected. Okay, so one let me see if it appears on domain. Okay, so in the meantime, we can we can see I have already generated this an equivalent resource group, so we can just start looking at the things in the meantime. So I created this. Sorry, we're going to go here to resource groups, and this is the resource group we are generating right now. This is the previous one. This is the previous one I had generated. And as you can see here, we have a lot of stuff that is created for these examples. Let's just take a look at the streaming analytics job first, so you can have a little bit of an idea of what it looks like until we created the hours, hopefully. So as you can see here, we have this top bar with a start button. This is when we are going to start the job to run. We are not going to do it right now, just because we're just waiting for things to be created. And we also, well, if you see the job, it has an associated input and an associated output that is going to be this storage destination, and the input is our IoT hub. And with this, also there is a query that is the query that we're going to run continuously. And maybe while this is creating all of this, let's check a little bit at the query. So this query, and here you can see, I'm going to just make this smaller. You can see the input that we're reading from. We can see the output, and you can see the query we are going to run. Since it's almost done here. Oh yeah, it finished here. So well, let's go back and let's see hours. So let's remember that you created this. This is the name of your resource group, but this is what you should look for here. So let's search for this thing, and then this is the resource group that we just created. We're going to see inside of it, and you should have these three elements there. This is the IoT hub that we created to store the data. Just take a look at it, just for the sake of seeing the data, seeing the service. This is where it is. So far, it has not received messages. We will see later on when we send messages to it that this will change. We also should have the destination storage, and this is a blob storage that will also have data. If you look at this data right now, we don't have anything. Again, we will see just afterwards. And then we have the streaming job. And the streaming job is here. We have not started it, so that's probably the next steps in the instructions. So, okay, so we have the three elements that I just showed. I'm going to just double show that before to be coherent with this. You see, you have an IoT hub with the code, a storage with the code, and a streaming with the code. So it says select the streaming one. And let's check that we have the good inputs and outputs. We have the IoT input, we have the blob output, and this job has a query. That's what I was just showing before. This is a query that aggregates messages. It counts messages every 10 seconds. Well, we won't go really deep into this query, but just want to show one thing is that in these queries, for streaming, we always have the time dimension somewhere. Here we group things by timestamp. We have concepts like windows. All of this we will see in the future section next Thursday. So that's it. So let's go back into our overview, and now we are going to run. So the first step here, go to the overview page and run the start query. So we are running the query. He asks us how many stream units we're going to assign. We're just going to go like that. Just let's wait a little bit also so this starts. It took less time, let's hope. And also, well, now we have to produce data into these systems. And like we said, we produce data by sending data from our telephones or from IoT devices. We are going to simulate this with a script here. And let's take a look at this script in the meantime. This IoT device.sh is creating a simulation of a device with sending data into the IoT hub. So it's producing data. So when this starts running, we are going to produce the data, and this data is going to be first stored into IoT hubs, then queried and aggregated, counted, let's say, by the Azure Streaming Analytics job. And finally, it's going to be all this aggregation is going to be stored as in a file system, no, as a resulting CSV or something like that. Okay, so this is running now. We are going to send the messages. Once we send the messages, I'm gonna go up here. Sorry, you will see. Sorry, I went a little bit too much. We are just run this command. Now it's producing this data. You will see this progression here. And it says, okay, now that it's running, let's go back into our resource group and look at the storage account to see if the files are being created. So let's go into our containers and data, and then you will find this new folder with the specific time of the day and this file that is being created. So if we click here and view and edit, you will see all these are records that are arriving at this time. As you can see, at the moment I click this, there were only 25. If I click on refresh, you will see that it's growing. No? Now we have more than 25, 41, another refresh, and then we have 50, and then it will continue growing as the data is a group. No? As you can see, this is taking this period of time from this date into this date and telling that for this device, it produced this number of messages. That's what our query was calculating. So let's do another refresh. And you see the destination data is being filled. Another thing that I wanted to show also is that if we go back into the into the resources and we look at our IoT hub, now we're going to see that it has received more messages. No, these are the messages that it has received, and of course you can see also all the graphical representation of this data. How many messages it has received into how many devices. Well, this is for if you want to go deeper into IoT hubs. So we are there. We are almost done. Oops. Hopefully you can see this below. Just go back into, into the storage again, just to check that everything is going well. Check. And here we have to view and edit the data. So here we are, 199. We're almost done. So now we are at the end. This is all the data is there. So this is all for the Azure Stream Analytics and how it works. Now that the simulation is finished and we have all the data that has arrived, we can go to Stream Analytics and stop the job. And let's not forget that these jobs are running forever. So if you are running it forever, well, sometimes we care about running for it forever. Most of the times we care about this, so we don't have to stop it. But since this is an example, well, we can stop it now. Okay, stop, check. And we are now going to, once this stops, we are going to delete the resource group. Let's not forget that also. This is going to happen. Okay. Let's not forget, if you are running this on your own account, let's not forget to delete this, because this uses, of course, your Azure credits. So. Okay, so let's see if this is the notifications. Is still running. Well, this should be done quite soon. Okay, so while this is stopping, let's go ahead and look at the next step. That is the next scenario is the Explore Apache Spark on Microsoft Azure. And Apache Spark is a distributed processing framework for large-scale data analytics. As I mentioned, this is part of an open source project and the Apache Server Foundation. This basically is a way to write queries in a, let's say, more step-by-step manner. And these queries, the advantage is that they can be distributed among many machines and with different systems like Azure and Synapse and Databricks, and of course HD on-site. So for this, we use a library that is called the Structured Streaming Library. It's an API, a programming interface that is supported in different languages, Python, Java, Spark, and also .NET. And with this, we can process continuously this data. This processes this data in groups that are called micro batches. So we're going to check a little bit also of how it works in practice. And one important thing here is that this data is processed, and the destination, as we mentioned before, is usually a blob storage kind of system. And normally people store these things in CSV files or some kind of data container file. This thing called Delta Lake is an open source storage layer. They call this thing also table formats, and has the advantage that it has already a schema pre-configured. It's optimized, its binary is optimized, it's stored as columns. A lot of kind of neat technical details that make it fast and convenient to store data into what we call data lakes. So this is a data lake storage format. So we are going to produce one of these in our exercise. So let's go into the exercise then. Sorry. So this, hopefully this stopped now. Oops, still stopping. Okay, so well, let's create a new resource group for this, and then I will delete this one. Okay, so let's create a new resource group. Wait, sorry, I forgot. Sorry, I was a little bit rushing this. So this is for this first scenario. Now we're back here in our lesson. We are going to, as I mentioned, this is a Spark, and this is what you saw in the slides. These slides are generated from this page, so nothing new. And now this is the exercise we are going to do. Okay, so the first step is we're going to create a new resource group. Well, we can maybe let it in the same resource group. So when I delete everything at the end, I will delete everything together. So in this resource group, we're going to create a new resource, and this new resource is going to be a Synapse Analytics. Which one is of the two? Well, let me go back here. Probably it's easier to read. Synapse Analytics. Okay, here we are. So we are going to create a Azure Synapse Analytics space to put our queries and all the stuff we're going to do with Spark. So first thing, well, we have to choose a resource group for this. Oh no, let's create a new resource group. I prefer to be clean with this. So Synapse Game of Learners resource group. Let's call this thing. Okay. Back. We also need to have a managed resource group. So again, we're going to call this thing Synapse Game of Learners Managed Resource Group. Yeah. Now we are going to give a workspace name. So as suggested there, we are going to put Synapse workspace. Well, let's call this GoL workspace. So we have all these. Oops, there's a typo here. Okay. And now we have to choose the region. Let's take, I'm going to take East US for this. Now the account name. So now we're going to, first step was to create give it a name to our instance of Synapse, to our workspace. So the next part is going to give a name to the data store, so the data lake. So we're going to call this thing, also create a new, again, same story, data lake, Game of Learners. Oops, this thing doesn't like this. Okay. Okay. And now we're going to create a file system also for this. Okay. File system for Game of Learners should be okay. Then we have everything. Now we're going to the next window. And here, this is something I noticed. It's not here in the documentation. they ask you to go immediately into review and create, and well, let's do this to see what happens. When you do this, you're going to probably see an error or an issue. Is the fact, it worked. Okay, surprise for me. It didn't work for me before. So let's create this. Okay, so let's go ahead and create this. It will take some time to create this, so let's jump back into Spark a little bit to understand what's going on at the time this is deploying the resources. And as you see here, we're going to deploy again multiple resources. Here we're going to deploy the data file system, the file system for data lake, and we are to deploy also the Synapse instance. No? So this is going on. While this is doing this, we are going to jump a little bit into Spark just to show you, to give you a little idea of how this thing works. So in Spark, you have, let's make this bigger, sorry. In Spark, you have, let's say, a session that you define on the system. And with this session, you start to do queries. And you do queries first by reading data. Sorry. You read data. In this example, they are reading data from a JSON file. Well, we can read data also from a directory with files, as I mentioned before. And then you can do operations with this data. And there are two kinds of operations. There are transformation operations. Let's say I change one column, I can do uppercase, I can filter data, filter by column, all this kind of stuff. Or I can do what they call an action. And an action produces an output as a computation. This forces me to produce a result. So show is one way to compute the data of this. And concretely in structured streaming, sorry, I'm a little bit jumping in all directions, but I'm going just to hopefully find what I'm going to show. As this is the official documentation. This is how it works. So basically, we are going to read from a stream. In this case, they are reading from a socket. So in our case, we're going to see where we are going to read from. That's in a second. And we are going to do transform to this by producing what we call a data frame. This df at the end of all this code usually refers to data frames. So let's go back here. Oops, let's go to the exercise. Sorry, that's not what I wanted to show. This is still creating things. It's creating the storage and the Synapse group. And in the meantime, well, they say once this is created, what we are going to do is we're going to open the Synapse Studio. That is a tool to create queries, to create data integrations. It's a really professional tool to do all this stuff. And we are going to create a notebook. Sorry, I'm going just to jump a little bit because I want to show the code before while it is creating all this stuff, so we can win a little bit of time. So you can have in this repository, the link is already there, so I won't go. You're going to find here this in the streaming directory, a notebook. This is the notebook we're going to process with Synapse later on. Okay, so we have this notebook on the right side. And this notebook basically is going to read data from a directory. It's going to read data that has this schema. So we define a schema, and this is important for Spark, that you always define a schema to read or process data, which is a good warranty. Let's say it's not like JSON that you don't have the data types here. You define it in advance. You define a device and a status. And then you read from this directory, and then you produce this file data frame, let's say. And with this, we're going to filter the error, the devices that are producing errors, and we are going to group them by device and count them. So we are going to count how many errors we are producing. And then we are going to store this into memory. And we're going to start. And we can also do this with queries with SQL, but well, let's see if it's finished. Yeah, perfect. This is finished, so we can now do it in practice. I just wanted to show how the programming model works a little bit. Let's remember that since this is continuous, we have still the same concept of starting and stopping the continuous query or processing task. So, okay, so we are here. we are going to jump straight into Synapse. We're in the Synapse group, so now we're going to go into our Synapse instance. And once you open Synapse in the portal view, you have the option to open Synapse Studio. That's what they asked us to do here in the step 7. So we are going to open this. This commonly opens in a different window because this is a different system, let's say. It's not just the Azure portal, it's its own system. Say any changes made? Okay, thank you. Automatic saving. Yes, I want to save every change it does. Here we can expand this and visit the different sections. Of course, we have a section to define data sources, to link with external data services. We can develop here queries and notebooks. We can integrate different systems. We can monitor our queries and ongoing processes. We can define what we call pools, and I'm going to just talk a little bit of pools in a moment. So we arrive here, and now we're going to create a pool. This is the next step. Oops, sorry. So what is a pool? A pool is a set of machines that are going to run our data processing. So in a single database that runs in one machine, well, we don't need to have these things because you only have one machine. Here you need to have two kind of elements. One that is a machine that takes control of the task, and the others are the machines who are really doing the task. So when we create a pool, we have this kind of mini cluster, let's say, or cluster, real cluster, that is going to do that. So let's create our pool. Let's see there. We're going to spare a pool called the spare pool. That's what it's called. Let's call it. Oh no, let's do that. Like spare pool. We are going to choose the memory optimized version. We are going to choose a small instance. Of course, you can see here there are many options. It's really bigger, but of course you pay more with this. And you can and these pools can auto scale. And what does it mean that we want? If we want a pool to us to scale, we want that if there is more data, we want to be able to process more data, so we can play with this slider and make it bigger. And here it shows you the estimated price for this. And also it can dynamically allocate executors. Well, when I disable this, what does this mean is that it can grow and add more machines if required, or just reduce it. But well, for our example, let's make it just a 3-node. That would be enough. Okay, so this also shows other things. It shows how many times is idle before it's stopped. And this is a really nice feature. You can stop this thing automatically, so you don't pay more. You can choose the version of Spark to run, and let's go. I think we can just go ahead and create this. Again, this is probably the one that is gonna take the longest, if I remember correctly. No, it's Synapse creation that was the longest. So, okay, so this is creating the pool. Why we need this pool? Because this is going to be the target of our query or of our transformation job, no? So, okay, still going. So let's go with the next step. So while this creating the Spark pool, and you forgot to mention that there are other kind of pools, no? There are SQL pools and Data Explorer pools. We will see Data Explorer later on. But well, this for the moment we only care about this Spark pool. So we are going now to download this file. Oops! Wow, that's not so nice. Let's go back. I'm gonna save this file. Okay, now we have the file here. And in the Synapse Studio, go into the develop page. So we're going to go here. Oh, here it showed that the Spark pool is already deployed, it's ready. And we are going to tell here, we are going to import, and we are going to import this notebook that we just downloaded in this step. So this is the same notebook I was showing before in GitHub. And now we're going to include it into Spark. So here you can see a warning. I'm going to reduce this because otherwise we cannot read. It's telling us, oh wait, you don't have attached this into a pool. So we are going to see how to do that. If I found it, let me just reduce this because it's still so big. So here we have the selection of the pool. If we had more pools, we could choose a different one. We're going to choose for the moment the Spark pool that is available. And there we are. We chose the pool, and now we're going to, this is a notebook. So for those of you who are maybe not familiar with notebooks, in notebooks we just put some text, and then we have cells, and these cells allow us to run code. Oh, it's not showing well, right? This is strange. Let's refresh this because here, okay, it's strange. Okay. Okay, so we can run each cell independently. So let's run the first cell just to test that everything is working. This is going to take a little bit of time for the first one because it has to start the session. So it's going to, what is happening behind the scenes right now is that there are 3 machines who are being started, and these machines are being provisioned, let's say, and getting ready to process the job that we are running in this notebook. So this usually takes a little bit of time. Sorry. And as you can see, well, this is the same code we were looking at GitHub. I just want to show you so you are aware that what I showed before is the same. See, this is the first step, but we cannot run it here in GitHub because we don't have the Spark pool and the system to do it. So this is running, and as you can see, we're creating just a directory. It shows the output here. Probably right now we won't see the output until it is done, but hopefully soon. And okay, so let's go back here again. And well, let's continue looking at this while this is running in the same page. So first we create this directory. Then this is Python code also for those who are not familiar. It should be relatively straightforward, let's say. We are defining a data frame that's going to read our files. This is reading using this schema that we define here that has 2 elements. The schema, like the schema of a table, it has 2 columns, device and status. We are telling him to trigger every time he finds a file, a new file, and he's reading from this path that we created just before. Then in the next step, we are going to count. We are going to first filter all the devices that have a status of error. We are going to group them by device, and we are to count. If you see, and if you're familiar with SQL, this is really like a select group by count, no? Of SQL, but it's done step by step, a little bit like pandas and all of these data frame libraries. Finally, with the results of this count, we are going to write this result into memory. We're going to count the counts, and we're going to start running. So let's hope this thing finished. Just some time. Slower. Okay, so well, let's continue and we will go back. In the next step here, well, this is to show that we also can run SQL with the Spark. We can just do a simple query, but notice that here, what I'm querying is this counts result that I created. I'm not, it's just aliased as if it was a table. But of course, if you think about it, we never put data into this thing. So the next step is to create some data. So here they define some data. We're going to define some data. We're going to put it into a file. And the funny thing is, since we created the new file, it's going to trigger the query. So once it's triggered, we can query this data and see the results. Let's see if it finished already. Oh, wow, super slow. Okay, let's wait a little bit. Sorry, demo effect maybe in action. Okay, let's clean this. Okay, so and then once we put this data into a file, it triggers the continuous job to filter things, and then we can query and we will see the results. We can also run to create a second file here. This is what we are doing here, creating a second file. that is stored into the file system, and then we query this again. Finally, the last part. In the last part, we are going to create a delta table. So instead of the output format before in the previous write was memory for the first one, here we're going to write into a file, and a file with the delta format. So we call this delta. We choose the location for this, and this file is an intermediary file. Let's say that is called in Spark a checkpoint, and then we can take this data that this directory, and we can read from this path and show the results. So let's hope it's finished now, and I can run out of this because I get tired of talking without seeing things. Okay, cool. This finished now. It was created, so it says true. So let's go now with the next step. This is creating the schema and reading the data. It should be fast because here we are not computing anything. You see, it was quite fast. We're not computing because we have not started the query, the continuous query, let's say, or the continuous transformation. And now here we are going to start for real the query because we have this start method. So now this is running. And as we said before, if you run this query, that should run in parallel, should produce no results. You will see. Still running. So no data available, of course, because we have not created data. We are going to create the first file. We're going to put this data there. So it says true, so it created the data. So now, since this is continuously querying, where we probably should have now a result, let's run the query again. Oh, oops. Okay, let's see if it's going to. It could maybe take some time also, since it has to capture the batch, the micro batch, let's say, of the execution. This is strange. Okay, so let's run this again. Oh, wait, I'm wondering if because of the notebook, this thing stopped the query. Oh, yes. Yes, I'm not sure if this is running. No, maybe it is. Yeah, it's started now. So maybe it has not detected the file. Let's try again. Let's try again with the query. Sorry. Ah, cool. So finally, it cached the results. This could take a little bit of delay. And this is interesting because in streaming systems, sometimes people think that things are immediate that we have it right now, but we have sometimes delays because of data passing from one system to the other and getting queried. So well, let's create the second file. Now that we create the second file. Okay, cool. The file was created. And then we're going to query again the second file. I'm going to give it a little bit more time to see if we can see a difference. Hopefully, we will see something different from these results, that the 2 and 1 files with errors. Let's remember there are 3, you see. 2 for the device 2 and 1 for the device 1. This is what he correctly aggregated here. And now we were having to have 1 more for each. So let's hope it works. And that's it. Then we have the counts that augmented. So this is pretty cool. So now, as I said, last step, we are going to register this into a delta table. Let's run this. This is probably going to take a little bit longer. Oh, it didn't. Okay, interesting. Okay, because we just defined that we have not written. So, no, yeah, it has already written. That was very fast. Okay, so now let's read the data into this data frame, and we are going to show this data frame. And you can see the results of the data that this is the data that is stored in the file system as a destination. No? So this is a delta table that we can see. And even with Synapse, we can automatically create a chart for this, which is kind of handy to understand the data. Then finally, we're going to, what is this? Oh, okay, let's do this. This is, so that's something I didn't mention. Delta format has an advantage, is that it's a version format. So every time we write things into it, it it creates versions. So we can visit the first version of the data. We can travel in time. This is called time travel. So this is a little bit to show this. And finally, let's not forget, as with all these systems, we have to stop them. Otherwise, they will continue running indefinitely. So this is the last step. We're going to stop the system, and that's it. Okay, so here we are done with the Spark part of the exercise. Let's go now to see the next system and the final system. Sorry, this is going a little bit long, but this is a long course. Is Azure Data Explorer. And Azure Data Explorer is a standalone service that was created at Microsoft, and this is a really internal Microsoft system. Let's say that if you notice the three systems that we talked today about, each one has its advantages. The first system was more into SQL people. The second one is more into like people who are familiar with data frame tools and data scientists and analysts. And this one is more like for people who are, let's say, more into the Microsoft sphere of systems, and who also are familiar with telemetry, time series, and this kind of stuff. So this Azure Data Explorer is interesting because it uses a different query language. As you can see here, the query you can think about it as if you had data and then you pass through a pipeline and do an operation into this data. So you are going to filter, for example, this data because of this for the start time or for the type of event. This is how it works. This language that is called Custo is Custo query language. That's what is called KQL. Was invented by a team in Israel, and it's interesting because the name Cousteau is because of Jacques Cousteau, the French researcher and activist, let's say eco-activist, and because he explored the deep of the ocean. So this is to explore the deep of the oceans of data, let's say. So let's now go into the exercises. So we see a little bit more of Cousteau. So hopefully this will be quicker. We go here into the last exercise. Okay, so the first one things we have to do is to provision an Azure Synapse environment. We already have one, so we are lucky with that. We don't have to do this. We are already there. We are going now to create a pool. Well, here they mention if you don't have a Synapse analytics service, well, you have to instantiate it and all these steps that we did before, but we don't need that. We're going to go straight to create a Data Explorer pool. So we are going to say here new. We are going to give it a name. Let's call it again DX pool, game of learners. We're going to choose a type of workload. In our case, we're going to choose compute optimized, and we are going to select the size. We're going to take a little small instance of this. Okay, we're going to review and create. Okay, it's cheaper. Let's do this. Oops. It says that it's going to take like 15 minutes to be created. So, wow, that's way more than I would have hoped for. So this is super long. Okay, so let's wait a little bit. In the meantime, we can see other stuff as we did before. So in Synapse Studio, let's go into the data part. And we are going to create, so as I said before, we can have different databases. I'm going to close this, sorry, I forgot before. Stop session, I forgot that. Check, that's from the previous session, sorry. So we can create or integrate data sources from different systems here. For example, we can take a SQL database that we have, Azure SQL, and put it here to use it in our queries. We can also integrate a lake database, data lake. And what we want to do here is to create a Data Explorer database, but since this is still being created, I think I cannot do it yet. This is still creating, so we have to wait a little bit. So while we wait, let's check out the rest. The next step that we have is we have to download this file. So let's call this devices file. Okay, and let's check what is in this file. In this file, we have a time value, we have the ID of a device, and we have a value of a measure that it takes. It could be, I don't know, temperature or some kind of data that it captured. So, and okay, so now we have to import this here, but we cannot do it until this thing is deployed. Hopefully more quickly than this, but 10 minutes are a bit long. And once this is created, we are going to import the file, and we are going to put it as a destination of our Data Explorer pool. So we are going to do queries with this file. Let's wait a little bit until it's created. Trying to think how long did it take when I tried this before. I just wanted to mention something, and let's maybe in the meantime let's look at the Custo and the Custo query language. This is interesting. Oops, I'm gonna close these things. This Custo query language, one thing that is interesting, and if you are into DevOps kind of systems, is that is really used into the Azure Monitor, for example, to monitor what's going on with telemetry and databases and about the different systems, that are running on Azure, and also for Azure Sentinel, that is Azure solution for security. So learning Custo query language is quite useful if you are into the Azure ecosystem. So what is a Custo query? Let's say a Custo query is a mix of some things. There is usually what they call an expression. That is, this is the source of the data, and then we do these transformations in each step. Basically, if you see here, we're going to filter events that are between these two dates, and then that belong to this state in the US, and then we're going to count them. This is to count how many storms happen, for example, for a storm data set. So just for familiarity, let's think that these are like Unix pipelines that we are going to transform data step after step. It's kind of nice to look at the queries at least. No, this is still deploying, kind of slow. Let's wait a tiny bit, maybe. So well, let's go back to the exercise in the meantime. So once we have this, what we are going to run is some of these queries. The basic query is just to put the data set name, like a table, and with this name, well, we're going to get the results of the data we have. All this result that we checked in the file before. And then we are going to use instructions like take. Take is basically like take the first 1,000 rows or elements of this collection, let's say. Then also, well, we can do queries like that filter data, and then we can also make queries, more complex queries that filter also by time differences and that group data. That's interesting. For example, here in the last query, we are going to query data that is in a time range. There's this group, and this is interesting because in Custo you don't group. When you group data, there is this keyword that is called summarize that you use to do aggregation, so averages, sums, these kind of operations. And then you also have the sort operator. We don't really go more deep than that into this module, but it's so you get familiar with the other way that you can create the queries. Okay, let's go back here to see if this is done. Otherwise, it's still taking longer. Okay, so maybe maybe let's look at this in an existing system that I have. It's probably going to take longer, and there's no reason to wait for this. Let's go into Synapse. Sorry, I have this. This is a previous workspace of Synapse that I created for this example. We are going to look at here, so we don't lose more time. And as before, I'm going to close this so I don't get confused. Okay, well, let's let it far here so I don't get messy with it. I'm going to open this, and Okay, so as we said before, we're going to create this data, and I already did this step here. So here we have this pool that has the data, and this has the devices file that was created. I'm going to give it a benefit of the doubt that is created, but no. So I'm going to see, can I delete this thing so I can show everything? That's the good question. Otherwise, okay, so let's do the query. So what we have to do here was to create the pool, what we just did. Then after creating the pool, we had to import the data. So let's import the data again. Maybe I suppose I can do that. So we are here in the data tab, and let's say, trying to find this. Ingest new data. Oh, oops, sorry. Oh no, this didn't finish. Okay, so let's in Synapse Studio wait for the database to be created. Then in the next browser tab. Oh wait, that's my mistake. So I should have done this. So here you also, when you're joining a Data Explorer database, you have a different system to run the queries on. A part of the, as we have, for example, this Synapse view, we also have a Data Explorer view. And this is where we import the data. That's why I was not finding things. So here it says ingest data. So let's gonna do this. You see, now we're talking. We have this pool that we created. We have the database that we are going to use for this, and this is the table. So I'm going to create a new table. I'm going to call it devices 2, because just to show that it's a different one. The source type is a file, and I'm going to look for my file. That is this. I hope this is smart enough to understand that it's a CSV. No, it didn't. Let's tell him he's a CSV. And he understood that it's a CSV. He did the mapping. Let's ignore the first record because this has a header. So there we are. Now, so this is the same import we said here on compress, CSV, selected, and device mapping. Cool. So this should be ingesting now the data. And there we are. So that's much better. So now we have the data ingested. And we can run the queries in the existing pool. So let's query these devices. Hope devices 2 works. No, devices. Oh, wait. So I have not selected the database to query. Wait. Wait, let me just, because I don't know where I am. Okay, so. Oh, oops. Let's do this. Devices 2 run. Here it's protested because the syntax is not good. Now we are talking about it. So, okay, so now we are running the query. We have these devices that in the example is called devices only, but I call it devices 2 because it was my copy that I did to show you. And now we're going to run the other queries. So let's make the first query. This takes the first 1000, but I can do this just to show the result that I'm going to take the first 7, let's say. You see, it takes the first 7 results, not 1000. Also, we can use, we can do this other query, and we filter only for one device because we only want to know about information about one device. That's how we do it. And then we can also now take this information about one device, but in a specific date. So all the operations that happen after the first this date in January, and there we are. And also, well, now we're going to run into this query that also aggregate and summarizes. So we're going to calculate the average of these numbers. So let's do that. And there we are. We have the average of the measure of each of these records per device. So we finally finish with all the steps. Now we are going to go into the last part of this. So we are over with exercises. We are going to delete our resources. I'm closing things here. Let's not forget to delete the resources that we created. Remember, you can do this, sorry, not here, but in the main portal. You go into the resource groups and you choose the resource group that you created. Remember, it was this one. Then you look for this. You go inside and you choose delete resource group. It's going to ask you for the same name of the resource group, and you are going to delete the resource group. I'm deleting the previous resource group, but we have the other resource group to delete. So there we are. Let's go back to our presentation. We are almost done. Sorry, it was a little bit longer than expected. So the last step, maybe we can stay here. In this page, we have now the knowledge check. So we are going to check the questions. So which definition of stream processing is correct? Data is processed continually as new data records arrive. This is, yes, this is part of stream processing. Data is collected in a temporary store and all records are processed together as a batch. So this can happen, for example, once per day or something like that. No, this is definitely no stream processing. Stream processing is about real-time analytics, so it happens continuously. So it's not this one. And data is incomplete and cannot be analyzed. Well, the fact that data is incomplete does not mean that it cannot be analyzed. As we saw, we can wait more time, for example, to get more data and analyze it. So this is not also a definition. So let's think that is the first one. Second question is, which service would you use to continually capture data from an IoT hub, aggregate it over temporal periods, and store results in Azure SQL database? So what kind of system we use for that? Now we want to transform these things and aggregate it. So, well, Cosmos DB is a database. Well, we use Cosmos DB to store data and run queries on it. We use Azure Stream Analytics is a continuously query system. That's what's a stream processor. So definitely this is probably the answer. And Azure Storage is just a storage system. This is like a distributed file system. So this is not definitely something we use to aggregate over temporal. So this is not. One thing that is interesting here is that, as you see, we can store results in Azure Stream Analytics because it also includes a data store inside of it. So finally, which language would you use to query real-time log data in Azure Synapse Data Explorer? And of course, well, one thing that we talk a lot about this with Data Explorer is that it uses a specific type of language that was called custom. So we know that SQL is not the case. SQL is what we use for stream analytics. Python is what we use for the Spark case. And in this case, we can talk about that is custom, the custom query language. So we check our answers and all is good. So now we are at the end. So well, let's go to the summary. Also, let's go to the slides maybe. Sorry, I can't go through this. So, well, we just visited the differences between batch and streaming processing systems. We talked about the specific elements of the streaming systems, the concept of time that is behind all the systems, the fact that we always have like a source, processor, and a sink as part of those. And we also define the capabilities of the different systems that Azure supports. So now the next steps, of course, well, is that you go deep into this if you are interested, and you continue learning about more of these data-related workloads, so into the Azure Data Fundamentals certification. Oops. And let's not, and we probably are going to end here. Now we can go. If you are interested into this, let's not forget that you can continue following our Game of Learners path. In the following weeks. In the next session, we are going to talk more about Azure Stream Analytics. We're going to review some of the concepts we discussed today. So yeah, that should be it. Do we have any questions maybe, Paul? Are we done? Oops. All right. Oops, something was. Okay, I'm going to stop this. Thank you, everyone. In case.
All right. I think we're still live. We'll need to edit later. But yeah, if anybody's watching right now, thank you all for attending. We're just trying to close the stream up. It's a pleasure.
Yeah, please let me excuse myself. Maybe there was a little bit of noise at the end because my kids just arrived home while I was doing this. Sorry, but and also while we get a little bit confused with the ending because we didn't have feedback. I don't know why. So. But well, don't hesitate to ask questions and continue the discussions in the chat or in the forum from the link I shared at the beginning.
Okay. Well, thanks everybody.
Thank you. See you later. Thank you. I'll see you in the next session.
Cheers.
Bye.